welcome back students to standard 10th physics chapter 10 light, reflection and refraction, and we are in the 11th session. In the previous session we learnt about refraction and we also studied the laws of refraction using a very simple activity of glass slab. Correct children? Now, yes, how refraction takes place in prism. We are going to see that. Okay. Alright. Here is prism. Okay. Now, it has 5 faces. 1, 2 and 3. Rectangular faces. 1 and 2. They are triangular faces. So, 3 plus 2, 5 faces. Out of which 2 are triangular. A simple activity we are going to do. Alright. This triangular face, I am going to place it on a white sheet of paper which is kept on the table, correct? And on this face, I am going to incident the light. I am going to incident the light. Of course, the light produced by the laser torch. Okay? Alright? So, after placing, I am going to put a torch and allow the light to incident here. And then we will take the aerial view. ऊपर से देखेंगे what is happening. Alright? ये लाइट हमको दिखाई देगी, फिर अंदर कहाँ जाएगी और बाहर कैसे निकलेगी. So if we take the aerial view, what we will observe? Let us see in the form of diagram. Alright, so here it is. This is what you will see. Of course, this black line is normal. This dotted line is representing how this incident ray would have traveled in absence of media, correct? This blue ray also would have traveled straight in the direction of dotted line if there was no change of mediums. Is that clear? Okay. Now look, this is the ray of light incident. So this is incident ray. Alright? Well, here the same laws of refraction would be followed. You check out. See? Now this light ray would have traveled straight if there was no air to glass medium available. Correct? But instead of moving straight, it's going to bend. Now you know air is a rarer medium and glass is denser medium. So when light travels from rarer to denser, it bends towards the normal. So see, instead of traveling straight, the ray of light falls. It moves towards the normal. The black line is normal at the point of incidence. So instead of, it would have made this angle, but the angle is now become small. So that means, yes, the ray of light has bent towards the normal. So it is following. See the other law. This is normal. Incident ray is on one side. Reflected ray is on other side. Incident ray is in air. Refracted ray is in glass. Clear? Next. Now consider the blue ray in the prism as incident ray. Alright? Now, instead of traveling straight in the direction of dotted line, it's going to bend because from glass medium again it's going to enter the air medium which is a rarer medium, correct? So it will follow the same laws. See this black line is normal at the point of incidence. Alright? This blue line incidence here, black line is drawn normal. Now it's not going to travel straight from denser to rarer. When light travels from denser to rarer, it bends away. So see, this dotted line would have made this angle, but it makes a bigger angle, larger angle. That means it bends away from the normal. Here, this is how the light ray is going to get refracted in the prism. Are you getting me? Children, this ABC represents prism. Now this I am going to call it as base of the prism. Alright, which is placed on the sheet of paper. Alright, now see this. This final ray which is coming out, emerging out, making exit from the prism is called emergent ray. It is called emergent ray. Do you remember how was the emergent ray and the incident ray in case of glass slab? It would have bent like this and then it would have traveled like this. So if you extend the incident ray and the emergent ray, they are parallel to each other. It is not the case here. It is not the case here. Now see, for you to understand, I am drawing a serpentine line. This is the direction of incident ray. Direction of incident ray. This is the direction of incident ray. And this is the direction of emergent ray. They are parallel. Here, the direction of emergent ray, if I extend like this is the direction of emergent ray. Now in this case they are parallel. In this case they are not parallel. That means they intersect and make an angle. Say suppose this angle is theta. This angle theta is known as angle of deviation. Angle of deviation. Children, in case of glass slab, the two directions are parallel. Incident ray and emergent rays are parallel. So angle of deviation is 0. That means there is no deviation between the incident ray and emergent ray. But in case of prism, the incident ray and emergent ray, they are not parallel and they make an angle theta, which is called angle of deviation. Now what do you mean by angle of deviation? The angle formed between the incident ray and the emergent ray when refraction takes place in prism is called angle of deviation. Is that clear to you? Alright. So these are the two differences between how refraction takes place in glass slab and in prism. The laws of refractions are followed in the same manner in both the cases. But what is the difference? In case of glass slab, the incident rays and emergent rays are parallel to each other. In case of prism, the incident ray and the emergent ray make an angle. They are not parallel, so they make an angle, which is angle of deviation. Here the angle of deviation is 0. Here the angle of deviation is any angle between 0 and 180. I hope you have understood how refraction takes place in prism. The laws are same. They follow. In both the cases, the laws of refraction followed are same. Well, now we shall see when incident ray falls on one of the rectangular face of prism at a different angle. Okay? Here, if you remember, I took this for the activity. This was the angle of, I have to draw normal, definitely normal here. So this was the angle of incidence. Now instead of traveling straight along the dotted line, it bends towards the normal. Matlab downward, thoda niche gaya. Right? Now this is the point of incidence and this is the normal, this is the angle of incidence. Now instead of traveling straight, it's going to bend downward. Correct? Are you getting me, children? Here we do not have any idea how much bending will take place. But yes, when it travels from rarer to denser, it bends towards normal. And from when denser to rarer, it bends away. But how much bending is there, we do not know. Very soon, I'll show you how that problem is solved. Okay? Fine. Now say suppose I incident a light ray perpendicular. Children, now this is perpendicular. So you know when a light is incident perpendicular, there is no bending taking place. So this will travel straight without bending. So this is incident ray and this is refracted ray, but no bending takes place because it is in the other medium. But here, at this point of incidence, draw the normal. This is the angle of incidence. Refracted ray would be on the other side. From denser to rarer, bends away. So this light ray will not travel straight now. It will bend away. Now you can see the normal is here. उससे दूर जाएगा. So it bends towards the base. Prism का base के तरफ नीचे bend होता है. Is that clear to you, children? Yes, you just apply the laws of refraction of light. That's it. Chaliye. Now, one more incident ray we'll see. Here is the incident ray. Correct? This is not perpendicular to the face. Here, I'll draw a normal. This is angle of incidence. Rarer to denser, bends towards normal. Alright? So, ये सीधा नहीं जाएगा. It won't travel straight towards. Correct? So, ऊपर जाएगा थोड़ा. This is how it is going to travel. Instead of traveling, it bends towards the normal. So, this will be the refracted ray. It incidence here. I'll draw normal here. Now, from denser to rarer, bends away from the normal. So, यहाँ से यहाँ सीधा जाने की जगह पे away from the normal. ये normal है. Normal से और दूर जाएगा. So, it bends and moves in this direction. See, you just don't worry about the incident rays. When you draw any incident ray, you see how it follows the laws of refraction of light. Clear to you, children? Sure? Alright? Yes. Now we shall see how lenses are formed. Okay? Look at the diagram, children. See how the two prisms are arranged. The two bases of the prism are coinciding. Correct? This arrangement forms a lens. And it is called convex lens. This is convex lens. When two bases overlap each other and form the structure as shown in the figure, then convex lens is formed. Is that clear to you, children? Now what happens, children? Please try to understand. I'm going to draw all the rays. This is first incident ray. Correct? This is second incident ray. Alright? This is third incident ray. And this is fourth incident ray. All the incident rays that I have drawn are parallel to each other. Let's see how refraction is going to take place. Children, here, this is the normal, correct? Now, instead of traveling straight, it's going to bend towards the normal. Air, rarer medium. Glass is denser medium. And again air, that is a rarer medium. Correct? So, rarer to denser towards the normal. So, ये सीधा नहीं जाएगा, नॉर्मल की तरफ ऐसे बैंड होगा. करेक्ट? बहुत ज्यादा बैंडिंग बता दिया. ऑलराइट? We have a problem here कि ये बैंडिंग बहुत ही ज्यादा है. And we do not know exactly how much it will bend. Doesn't matter. I'm going to show you a solution to that. Here is a point of incident now. This is normal. Alright? ये अभी सीधा नहीं जाएगा because change of medium is taking place and it will bend still downward. क्यों? क्योंकि यहां से यहां एंगल फॉर्म होना चाहिए, but denser to rarer bends away. मतलब और दूर चली जाएगी वो रे. And this will be your emergent ray. Is that clear? Let's see the next one. Here is the normal. It's not going to travel straight. It's going to bend. It's going to bend here it bends. I'll draw normal. It bends towards the normal की तरफ. यहां एक normal draw करता हूं. Now it's not going to travel straight. It's going to bend away from the normal. So मतलब यहां नीचे. That's it. Okay, this is the emergent ray. इसकी बात करते हैं now. I'm going to draw normal here. Try to understand. This is not going to travel straight. Now be careful. The base is upward. ये प्रिज्म उल्टा है. Base is upward. आप उसको मत ध्यान दो. यहां ध्यान दो. चलो. From rarer to denser bends towards the normal. अभी ये सीधा नहीं जाएगा. Normal की तरफ जाएगा. तो normal तो ऊपर है. So it's going to bend like this. Upward. Base की तरफ bend होने वाला है. Now this is not going to travel straight. यहाँ normal draw करता हूं and it bends away from the normal. वो normal से दूर जाएगा. मतलब ये सीधा नहीं, normal इस तरफ है, उससे और दूर जाएगा. And this is how it's going to bend. This is the emergent ray. Look at this. This is the point of incidence. Let me draw normal. Correct? ये right angle. Now it's not going to travel straight. और straight नहीं जाएगा. Rarer to denser bends towards the normal. So ये अपना normal उस तरफ है, उसके तरफ bend होगा normal की तरफ. There it is. This is how it's going to travel there. At this point of incidence, let me draw normal. Correct? Now it won't travel straight. It's going to bend away from the normal. Okay? तो ऐसे नहीं जाएगा. Normal इस तरफ है. If I bend this way, it is bending towards the normal. But यहां तो it bends away from the normal. और ये रही वो emergent rays. Oh children, ये जो convex lens बनाया, उसमें all the rays parallel to principal axis, वो मैं बताऊंगा. All the incident rays which are parallel to each other, after emerging out of the convex lens, they converge at one point. So it is also called converging lens. Is that clear to you, children? Okay. Now let's see how other form of lens is formed. Okay. All right, children. See in the diagram how the two prisms are arranged. Of course, I'm going to cut this part, so this part is removed, and this part is also removed. All right, and made over just one. So this arrangement gives you a lens which is called concave lens. Of course, this end and this end, yes, it's like cave. The cave, all right? So it has termed as concave. Now let's see how refraction takes place here. Parallel, 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 parallel. So I have taken four incident rays which are parallel to each other. This is the point of incidence. Let me draw normal. Now this is air, glass and air, which is rarer medium. This is denser medium and again a rarer medium. Now it should travel straight, but it will bend because the light enters from air to glass, from rarer medium to denser medium. When it travels from rarer medium to denser medium, it bends towards the normal. ये ऐसे नहीं जाएगा, ये लाइन सीधी लाइन में नहीं जाएगा, वो जो नॉर्मल दिखता है उसकी तरफ बैंड होगा. So like this it will bend. यहाँ कितना बेंडिंग होगा पता नहीं, लेकिन मैं उसका सॉल्यूशन दिखाऊंगा. So this is where the refracted ray will travel. वो अब सीधा आगे नहीं जाएगा because again it enters air medium from glass medium. So at the point of incidence, let me draw normal. This is normal. All right. Now it is not going to travel along this direction. ये डायरेक्शन में नहीं जाएगा. and it bends away. Away. So like this, it will travel. Correct? इस तरफ नीचे लेता तो it would bend towards normal, but it is bending away because it travels from denser to rarer medium. It follows the laws of refraction of light. Clear? Now very quickly I am going to show you here. Normal. It won't travel straight. It will bend towards the normal. So इस तरफ जाएगा. Correct? Here normal. It won't travel straight. It will bend. Okay, it will bend away from the normal. So ऐसे ऊपर जाएगा. Correct? Now this one, be careful. Here is the normal. It's not going to travel straight. Bending will take place from rarer to denser towards the normal. इस बार normal इस तरफ है, सीधा ऐसे नहीं जाएगा. Normal की तरफ bend होगा. This side. Okay? Then here I'll draw normal. It won't travel straight. It's going to bend from here and away from the normal. इस तरफ bend करूं तो normal की तरफ जाएगा. So away. Like this it will travel. Is that clear? चलिए. Here normal. It's not going to travel straight. It's going to bend towards the normal. यहां से normal नीचे तो normal की तरफ जाएगा. Here normal draw करो. फिर it won't travel straight. It will bend away. So here it is. This is how it travels. Children, actually these rays will never meet each other. ये चारों rays एक दूसरे को मिलेंगे नहीं. They diverge from each other. The rays, if incident rays are parallel to each other, after refraction from concave lens, they diverge. They will not intersect. So that's why concave mirror is also called, concave lens is also called diverging lens. Correct? But very interesting, children. If this ray and this all emergent rays, if they are extended backward, all right, they all seem to meet at one point. A little bit adjustment is done, but they will meet at one point. All right, they are diverging. In reality, they will never meet each other, but when they are extended backward, they meet at one point. Is that clear to you? Now see, what is the solution? कितना बेंडिंग होगा वो हमें पता नहीं है. सो कितना बेंड करना, 2 बार बेंड करना पड़ेगा. So we do not know. But after learning this, what scientists discovered? Let's see. Look here, children. Exactly in the center, I'm going to draw a very fine, faint line in both the cases. All right? And I'm going to draw those parallel rays. Till that line. यहां से बेंडिंग मत करो. Not from here, which actually bends from there. Alright? And you know, they meet at one point somewhere in this line. We'll see that. We are just learning the basics now. So सीधा यहां से वो पॉइंट के अंदर से जाने दो. यहां से सीधा पॉइंट के अंदर जाने दो. From here, straight away, let it pass through that point. And from here, so your drawing becomes easier. Draw करना आसान बन जाएगा. Ray diagrams draw करना आसान बन जाएगा. Correct? And in this case, yes, parallel rays, center तक ले लो children. These are incident rays parallel to each other. अब इस बार आपको कोई पॉइंट यहां लेना पड़ेगा, यहां. और ये जो बेंडिंग है, इस पॉइंट और इस पॉइंट आपको ओ रखना पड़ेगा. ये है. फिर ये पॉइंट और ये पॉइंट रूलर के साथ जोड़ दो. एंड दिस इज योर इमर्जेंट रे. दिस पॉइंट यहां से बेंडिंग होने वाला है, इसको जोड़ दो, दो पॉइंट को, एंड दिस इज द डायरेक्शन इट मूव्स। ये पॉइंट और ये पॉइंट को जोड़ दो, yes, in this direction it will bend. So see, they are diverging, but when you extend them backward, they meet at one point. Is that clear? So no need of showing 2 times bending. All right? Okay. So children, now we shall see actually how the lenses are prepared. They are not exactly like this. थोड़ा basics refraction को समझने के लिए मैंने ये दिखाया. Okay? All right, children. So let's see concept of convex lens. Exactly how that lens, which is having spherical surface, is formed. Okay? Now see here. Just imagine these are two solid spheres fused together, and these spheres are made up of transparent glass. ये दो ट्रांसपेरेंट ग्लास से बनाए गए सॉलिड स्फीयर, दे आर फ्यूज्ड टुगेदर, दे आर जॉइंड टुगेदर इन द वे यू कैन सी इन द फिगर. ऑलराइट, एंड देन फ्रॉम दिस फ्यूज्ड ऑब्जेक्ट वी कट दिस पार्ट. ऑलराइट, this single piece that we got from the object behaves as convex lens. All right, this convex lens has, it is solid object made up of transparent glass. It has spherical surface green and spherical surface red. This red spherical surface is of this sphere, and this green spherical surface is of the other sphere. Both the spheres have its own center. This is red center, C1, let me say, and this is center of the second sphere, C2. All right, children. Okay, this center, both are called centers of curvature. They are called centers of curvature of convex lens. All right, so a lens has two centers of curvature. Is that clear? This is a single solid piece, solid object made up of transparent glass having bulged spherical surface on its both sides. Okay, it is bulged out. Okay, it has centers of curvature. Now imaginary line which passes through the centers, that is called principal axis. That is called principal axis. Is that clear to you? Now exactly there is a point which is central point of this lens which lies on principal axis, that is symbolized as O, and it is called optical center. What it is called? Optical center of convex lens. Is that clear to you, children? Let's see the concept of concave lens. Okay, now see, here we have two solid spherical objects made up of transparent glass. Now what I do, I'll take one part from here, spherical part from here, and other spherical part from here. Now this is interesting. Then I make a single piece of glass in this shape. Now this is concave lens. All right. Actually, this is not the way of making them. I am showing you how concave lens is formed. The preparation is totally different. Now this single piece of transparent glass in the form of shape that you see here is concave lens. Yes, it has two spherical surface. All right. Okay. And this edge, it may appear very thick to you, but it is actually quite thin. It appears quite wide Otherwise, it is very thin. Yes, it has this spherical surface. All right. And here there are two spherical surfaces. Once again, this is center of green circle, let's say. And this is center 2 of red circle. Now this green spherical surface is a part of first sphere. The red spherical surface is a part of second sphere. Alright. So again, convex lens has two centers. Once again, if you draw imaginary line passing through these two centers, then it is called principal axis. It is called principal axis of concave lens, exactly in the center on the principal axis. Yes, concave lens का एक central point होगा principal axis ऊपर, उसे कहते हैं optical center. It's called optical center. Its symbol is taken O. So I hope that is clear to you. Okay. All right. Now we'll see what we learned today, children, in this session. All right. What is lateral shift? Try to understand. Here, an oblique incident ray incidence at this point on one face of a glass slab. I'll draw normal. Correct? Now it is going to bend towards the normal. You know, it follows the laws of reflection. It bends towards the normal. So this is a refracted ray. Now this refracted ray can be imagined as incident ray in the glass slab. Now it will not travel straight, but it will bend away from the normal. Correct? It will bend away from the normal. Right? Right. Now this emergent ray and incident ray, if you extend them, all right, you will find they are parallel to each other. Correct? In case of glass slab. In case of glass slab, they are parallel to each other. Correct, children? Okay. Now, the यहाँ से कहीं से भी ले लो, the perpendicular distance, suppose this point is C and this point is D. This perpendicular distance between these two rays is called lateral shift. उसे कहते हैं lateral shift. Alright? So when a ray of light is reflected from two parallel reflecting surfaces, children, this and this, they are two parallel refracting surfaces. The emergent ray is displaced from the direction of incident ray. Children, ये incident ray जा रहा था, लेकिन suddenly emergent ray यहाँ आ जाता है. So it is displaced. Incident ray is displaced to form emergent ray. Alright? Please try to understand. When a ray of light is reflected from two parallel refracting surfaces, the emergent ray is displaced from direction of incident ray. Incident ray की direction से वो displace हुआ. This kind of displacement is called lateral shift. And how much is the displacement? Equal to CD, the perpendicular distance between the two parallel lines here. Okay. Now note, this amount of lateral shift depends upon the perpendicular distance between the two refracting surfaces. Children, ये refracting surface बड़ा हो, मतलब instead of this थोड़ा बड़ा glass slab ले लो, तो distance between the two refracting surfaces increase हो गया, तो lateral shift का distance भी बढ़ जाता है. So this lateral shift depends upon the perpendicular distance between the two parallel refracting surfaces as well as the angle of incidence. Yes, जैसे जैसे आप ये angle of incidence बदलते जाते, red का ये कर दो या ये कर दो, तो यहाँ distance between the two parallel lines यहाँ, that is between incident ray and emergent ray भी बदलते जाएगा. So that is the second factor, angle of incidence. and third, refractive index of the medium. Alright, glass, we'll learn about refractive index later. Glass, air, water, they are three different media, so they have different refractive index also. Okay, so the lateral shift depends upon three things: distance between the two parallel refracting surfaces, second, the angle of incidence, and third, the refractive index of the medium. Is that clear? Now see how refraction occurs in the prism. So let's say this is the incident ray. Here I'll draw normal. Right? Now this is going to bend towards the base. ये प्रिज्म का बेस है, बेस की तरफ बेंड होगा, ये ऐसा सीधा नहीं जाएगा, it will drop. So ये refracted ray. Once again I'll draw normal here. Sorry, that is not proper normal. This is normal here. Okay. Now instead of traveling straight, it's going to drop towards the base, i.e. it's going to move away from the normal. So ऐसे बेस की तरफ नीचे आएगा. करेक्ट. नाउ इसको एक्सटेंड करते हैं, emergent ray को. Emergent ray is extended, and let's extend the incident ray also. Correct? So this angle is called angle of deviation. So what is angle of deviation? The angle formed by the direction of incident ray. That green dotted line shows you direction of incident ray, and the direction of emergent ray. This blue line is representing direction of emergent ray. An angle between these two directions. Alright. And this happens in case of prism. Refraction from prism is known as angle of deviation. I hope that is clear to you. Moving ahead. Few terms associated with convex lens. First, centers of curvature. Alright. The centers C1 and C2 of the respective spheres, एक ये स्फीयर, दूसरा ये स्फीयर, of which जिसके surface of the lens can be considered. Yes, ये पहला स्फीयर का ये पार्ट is the surface of the lens. दूसरे स्फीयर का A part is surface of the lens. Alright? So once again try to understand. The centers of the respective spheres of which the surface of the lens can be considered as a part are called centers of curvature, respective surfaces. Clear? Note, the lens has two centers of curvature, C1 and C2. Alright? Same way, ये convex lens की बात हुई. Now concave lens. This is center C1 of first sphere, whose part is a curved surface of the lens. Second sphere, its center is C2. उसका ये part is curved surface of the lens. Correct? ये lens है अपना concave lens. Alright. So same definition. The centers of the respective spheres of which the surface of lens can be considered as part are called centers of curvature. Okay. यहाँ भी दो center of curvature, यहाँ भी दो center of curvature. Now what is radius of curvature? Alright children, actually yes, कोई भी point ले लो यहाँ से और ये center से जो भी distance है वो radius है sphere का. That is radius of curvature. और ये center और ये point यहाँ लिया, this is radius of curvature. लेकिन children, radius of curvature यहाँ बीच में एक लाइन लेते हैं और जो ऑप्टिकल सेंटर होता है, एक्चुअली दिस डिस्टेंस एंड दिस डिस्टेंस का डिफरेंस निग्लिजिबल है. डिफरेंस इज निग्लिजिबल. ऑलराइट. सो इट इज इग्नोर्ड. ये डिस्टेंस और ये डिस्टेंस इक्वल है. सो डिस्टेंस बिटवीन ऑप्टिकल सेंटर एंड द सेंटर ऑफ कर्वेचर इज कंसिडर्ड एज रेडियस ऑफ कर्वेचर. ऑलराइट. लेकिन जो डिस्टेंस ऑप्टिकल सेंटर और सेंटर के बीच है, it is the radius of this sphere, equivalent to radius of the sphere. So what is radius of curvature? The radii, इसका एक और इसका एक, plural, of spheres from which the curved surface of lens are formed are known as radii of curvature. They are shown as R1 and R2. Okay, this OC1 is R1 and OC2 is equal to is R2. Okay, that distance. यहाँ भी वैसे ही, यहाँ एक ऑप्टिकल सेंटर P ले लो. So this PC1, not P but O, OC1 is R1 or OC2 is R2. Children, actually ये distance is R1 but that is equivalent to OC1. दोनों में इतना फर्क नहीं है. That difference is neglected, it is ignored. Is that clear? Okay. Now what is principal axis? Principal axis is ये सेंटर, दोनों सेंटर से जाने वाली इमेजिनरी लाइन, दोनों सेंटर से जाने वाली imaginary line, that is principal axis. The imaginary line passing through the centers of curvature is known as principal axis. Now what is optical center? The central point. Optical center is central point, okay, of lens. Lens ka central point which lies on principal axis. The central point of the lens on the principal axis is called optical center. I hope children you all have understood the basics. All right, we will see some more basic in a different way in the next session. So we end up session 11 here. See you in the next session. Till then, goodbye. Have a good day.